All right, we are back, ladies and gentlemen, with William H. Murray, and the topic headline here is RSA security, RSA new research, but he's getting into the crypto discussion. Go ahead, Bill.
Here's where our principle comes into play. One must choose the key randomly and evenly from the entire set of possible keys. Given the number of keys in use and the size of the key set from which they are chosen, one would not expect to find any duplicates or collisions at all, much less 2 in 1,000. The implication is the keys are not being chosen randomly. Computers are deterministic. Getting them to generate random numbers is what mathematicians call a hard problem. Really hard. Hard is a mathematical term of art. That said, the authors assert that the problem does not appear to be associated with any single implementation of public key cryptography. Said another way, more than one team has failed to adequately solve the really hard problem. The authors assert that if one knows two RSA keys that share the same modulus, then solving for the private key is trivial. Not so trivial that it's going to be done likely in the life of your use of the key. Said another way, two keys that share a prime factor, if two keys share a prime factor, then solving for the private key by factoring, incidentally Arjun Lenster's mathematical specialty, is easier. Thus, they say, they offer no security at all. What they really mean is that they offer little security against them or their peers, a fairly small fraternity. This is where Ron was wrong and Whit was right really comes in, however. It seems that while duplicate keys are a problem for all methods, this part of the problem is unique to RSA. Those systems that do not choose two random numbers, as RSA does, are not vulnerable to this factoring attack. Well, really, factoring is an attack that's unique to RSA in general. Now, suppose that you are using one of these keys. Then you might be a target of opportunity. On the other hand, even if someone knew your key and one with a duplicate modulus, they would still have the same problem that the authors of the paper had, that is, in identifying you. Google doesn't index public keys. While the problem of identifying you might not be as hard as solving for the key without the duplicate, it is still much harder than the cost of other attacks against you. In their own defense, the authors say that to the extent that publishing this analysis reduces the security of those using one of these weak keys, they were reluctant to publish. That ethical practice would require them to notify the users prior to publishing. However, many of the keys could not be easily traced to their owners. The certificates that bind the keys to the identity of their owners did not contain adequate contact information, like email addresses and telephone numbers. Also in their own defense, the authors claim that their publication does not really reduce real security so much as it might reduce public trust and confidence. Of course, that's all too true. What is interesting to cryptographers, or even important, may be unnecessarily alarming to the general public. As I've said here many times, public trust and confidence is fragile. If broken, it may take generations to repair. It's the cryptographer's job to do this research and to publish their results. I suppose that they have done so as cautiously and responsibly as they might. However, they might well have broken something that they did not create, do not own, and cannot replace. It's our job to use their findings to ensure that the security of our implementations and to preserve the public trust and confidence. Our problem may not be hard in the mathematical sense, but it's hard enough for us to be called professionals and to be paid the big bucks. I'll post links to the paper and also to the New York Times article, which you might find a little bit easier to read. Uh, the paper is while it gives you enough information, it is a little bit obscure, and you have to dig into it and read other people's analysis of it to really understand what's going on. Tomorrow morning, early, I board a plane to go to San Francisco, where I will go see the RSA exposition. But I'm really not going out there for that purpose. I'm going out for the memorial service for our colleague, Gene Schultz. In the process of speaking at that memorial service, I surrender the opportunity to go to another memorial tomorrow for our colleague, Joe Lisi from NSA, who will be memorialized in Maryland tomorrow. Joe?
All right, Bill. First of all, safe flight, and have a good trip. And if you get over to the RSA thing, take some notes and certainly get back to us. And our best to the people out there and all the work that they've done over these years. Hopefully, you have a good reflection with all of that, and you meet some of your colleagues out there and get to network a little bit. All right. Other than that, have a great weekend, and we'll look forward to hearing from you next week. All right. Thank you once again.
Thanks.
All right.
So I haven't chosen next week's topic yet. Maybe I'll get an idea when I'm at RSA.
You may get a topic from one of your colleagues that you meet out on the West Coast as well. They may have some interesting things to discuss with you. You never know. All right. Thanks, Bill. Certainly do appreciate it. Everybody, next up on the program is going to be biometrics. All right. And, we always look forward to the editorials from Bill. And we're actually hoping that he comes up with some great stuff for next week as well in his travels out on the West Coast. Take care, Bill.
Thanks.
Right, bye now.